Hi, period 4, it's Mrs. Guest. I'm sorry I can't be there today. I just wanted to give you some pointers as you work to complete your tasks today. So the substitute should be asking you to complete up to number 42. At this point, you should already have completed up to number 32, so this shouldn't be a lot of work. However, if you haven't completed the problems up to 32, you're going to need to do that as well. So let me just draw your attention to a couple key points. For one, you're in the review of linear functions lines pack. That's the one we've been working with right along. Okay. Secondly, if I turn the page here, we have looked at a number of problems. I want to highlight some of the examples we've previously gone over. One of those would be number 17, where we were sketching from an equation that was in y equals mx plus b form. You can see the work here, how we went about doing that, how we found our y-intercept from the b value, how we then were able to use the slope 4/5, as we see here, to come up with what the rise and the run would be, and then to plot accordingly. Okay, so, please take a look at this. Pause it if you need to. Several of these others are also in y equals mx plus b form. Going on to the next page, where again at the top of the page you'll see some additional problems in y equals mx plus b form. Then we got a couple where they gave us the x-intercept and the y-intercept. And we talked about what an x-intercept and y-intercept are. The x-intercept being where the line intersects the x-axis. So if they told us that point is -2, we would plot -2, 0, starting from the origin out to -2, 0, plotting that x-intercept. And then they told us the y-intercept was -2. Well, that's where the line intersects the y-axis. So we said that would be at 0, -2, so it's on the y-axis at -2. We had 2 points and we could plot those. You should be taking a look at number 24 as well. Okay. And then finally, I believe in this section for graphing, we looked at one that is in standard form. Standard form is still an equation of a line, but it looks a little different than slope-intercept. It's some number times x plus some number times y equals some constant. Okay, and that's what we see the structure here. And we talked about a couple of approaches for how we could go about that. So staying with number 25, we talked about how we could use the intercepts idea. We know when x is 0, we don't go left or right, so whatever whatever the value of y is will be somewhere on the y-axis. So we let x equal 0. We solved for y when x is 0. Of course, 3 times or anything times 0 is just going to be 0, so that nicely dropped out for us. And we went on and said that then 4y equals -12, so y must be equal to -3, and that was a point on our line, the y-intercept. And we did the same thing then letting y equal 0, because if we don't go up or down, we know we're on the x-axis. Okay. And when y was 0, we knew when we input 0 for y, 0 times anything is 0. So we had 3x equals -12. When we solved for x, we got x equals -4. We found that point, -4, 0. That was our x-intercept. And we were able to graph the line. Okay, so you can pause the video, take a closer look at this if you need to. But you'll notice there are some other examples here in standard form that you might find using this method helpful to use for graphing. Okay. Now, continuing on to the next page. Yesterday, we talked about numbers 29, 30, 31, and 32. So I'm going to leave this visible here for a moment. We had an example where we had a horizontal line And we talked about how we would come up with the equation of a horizontal line. The one thing we see for a horizontal line is that for every point on this line, the y value is exactly the same. In this case, the y value of every point on this line happens to be 1. We looked at what we get when we try to find the slope, just picking any 2 points. We picked 0, 1 and 2, 1. And we found that the slope ended up being 0 divided by some number. And of course, 0 divided by anything is just 0. So if our slope is 0, that means our value of m is 0. So when we do y equals mx plus b, well, 0 times anything is 0. So we just get y equals b, the y-intercept. In this case, the y-intercept happens to be 1. That's where the line is going through our y-axis, right at that 1 or 0, 1 point. Okay. We also talked about a vertical line, which is very different. We looked at a number of points on the vertical line. What we noticed on the vertical line was that for every point on that vertical line, the x value was the same, happened to be x equals 1. We actually picked a couple of points to find the slope, and what we noticed here is when we tried to calculate the slope using our equation, we found that our denominator was 0, and anything divided by 0 is undefined. So this is kind of an exception. We can't really write this in y equals mx plus b form because our slope is undefined. So when we have a vertical line, the way we get around that is we notice all of the values are the same for x, and we can define the line by simply saying x is equal to, in this case, 1. Okay. For any vertical line, the equation will always be x is equal to something, and it's a matter of what we're filling in for the something. Just like for any horizontal line, it will be y is equal to something, and we're trying to figure out what we fill in for that something. These other two were a little bit easier. These were lines that had some steepness to them. We were looking to write the equation in slope-intercept form, so y equals mx plus b. To get an actual equation of the line, we need to fill in the m value, fill in the b value. We were able to pick off the b value, right, which is just our y-intercept, pretty easily from the graph. Here we could see that the line was intersecting our y-axis at 0, 2. So our b value is 2. Then we went on and looked at 2 of the points on the line. The y-intercept we already identified. And then we were able to easily see this point here as well. We could have used a formula like this to find the slope from those 2 points, or we could just use the graph, the grid in this case, to get from one point to the other, only going up or down and left or right using the grid. We have to use the grid. We found, well, we would rise 2 and we would run 2. Okay, both of those numbers were positive because we happen to be going up and we were going to the right. And so we found 2 over 2, a slope of 1. So our m value was 1, and we put that in for m. So we got y equals 1x plus 2, or simply y equals x plus 2. We know that 1 we don't have to show. Okay. And then finally for this one here, very similar. We were putting it in y equals mx plus b form. Here, when we looked at where the line intersects the y-axis, we saw that was 1 notch above the 2, so that was at 3. And that's what we put in for b. Okay. And then we found another point on this line that we could easily identify. It happened that to move from this point to the other one we knew using only the grid, we were rising 3, and then we were running 3. Those are both positive values because, again, we were going up and to the right. So we ended up, again, with a slope of 1, coincidentally. So we got y equals 1x plus 3, or we could just rewrite that as y equals x plus 3. Either of those would be fine. Okay? So that's what we were working on yesterday. Now as we move forward, and you're trying to complete the work for today, they were asking us to continue, I'll try to pull this out of the corner here, to continue writing slope-intercept, okay? And they got a little fancy here because no longer are they showing us lines, now they're showing us equations. And these equations have that form of something times x plus something times y equals a constant. These are standard form equations. Okay? And they would like us to write them in slope-intercept form. So we need to figure out how to go from this to this, which is slope-intercept form. Okay? And it's really not that hard. We just need to move some things around using our algebra skills. So we know to get to this form, we want our y term on the left, and we already have it on the left, so that's helpful. We want our x term on the right, and we want our constant on the right. Well, the constant is there, but our x term is over here on the left. Okay, it looks like that's a positive x, so the way we're going to move that out of the left side, since it's positive, we're going to subtract it. And we know whatever we do to one side, we need to do to both. So by subtracting it, we get x minus x, that's gone. We then have negative 2y on the left. We have 7 minus x. Those cannot be combined. They're not like terms. One has a variable, the other's a constant. So negative 2y equals negative x plus 7. And I'm putting it in that order because I see that's the similar order to what I'm trying to create in slope-intercept form. Okay, so we're very close, but this is y equals, not something times y equals. Right now I've got something times y. So how do I get rid of the negative 2 times y? Well, I just undo that multiplication by dividing. And I have to do that to both sides. Okay, so I've got y equals, well, negative x divided by negative 2. Well, that's just going to be x over 2, which is the same as 1/2 x. Remember, a negative divided by negative is positive. Okay, and then I have to do the same thing here. This is distribution. 7 divided by negative 2. Well, I'm just going to call that negative 7 over 2. Right? 7 divided by 2, that's the same thing as 7 halves. I got a positive divided by a negative, and that's a negative. And that would be my final answer. Okay, I'll show you one more, so then you can try these 4 here. Okay, let's look at this one here. 7x plus 2y equals negative 28. That's standard form. And I want to convert that into slope-intercept form. And I'm going to use my algebra again. So using the algebra, I want to move this x term over to the right. It's positive right now. Whoops, sorry, moving my paper all around. It's positive right now, so I'm going to get rid of it by subtracting. And I'll do that to both sides. 7x's minus 7x's is nothing. I'm left with 2y on the left. Negative 28 minus 7x, well, that's just negative 7x minus 28. I can't combine them. I can rewrite them in an order that I prefer, which would look more like this. And again, I've got 2 times y, and for slope-intercept, I want just y, so I'm going to divide by 2. 2 divided by 2 is 1. That leaves me with y. Negative 7 divided by 2 times x. Negative 7 halves x. And then negative 28 divided by 2. Well, negative 28 divided by 2 is going to be just negative 14. And that would be my final answer. Y equals negative 7 halves x minus 14. Okay. So you can give these 4 a try. All right. We should be done with the graphing. Hopefully everybody was, so you can draw your attention and focus more here. Okay. And then the last thing I'm going to show you, which is really pretty easy, and again, you can pause at any time, is just writing the slope-intercept form of an equation given the slope and the y-intercept, which is just our m and b value. Okay? If this is a slope of negative 10, a y-intercept of negative 5, y equals mx plus b, I'm just going to fill in M and fill in B. Y equals negative 10x minus 5. Done. Okay. So you can use that to try these here as well. See how you can do.